Now see here, a parallel plate capacitor has a capacitance of 2 microfarad. A slab of dielectric constant K is inserted between the plates and the capacitor is charged to 100 volt. So, when the slab is inserted and capacitor is charged up to the 100 volt and then isolated, then you have to calculate what is the new potential difference if dielectric slab is removed. So, now after the charging you remove the dielectric slab and what happens to the potential, and then you have to write how much work is required to remove the dielectric slab. See here, if there is no dielectric we can write C naught is equal to A epsilon by D, but when the dielectric material is introduced then we can write C is equal to K A epsilon by D, and this capacitor is charged to the at the V is equal to 100 volt. This is the charging of the capacitor. So, now when the dielectric constant is removed, then what happened the C naught? That again it means dielectric constant is removed, again the capacitor will become this one of this. So, we can write here C naught is equal to C upon K. It means capacitance becomes 1 upon K times. Now, we can write here if the capacitance is reduced to 1 upon K times, we can also solve for the potential difference. So, we can write V naught is equal to, because in this process charge is constant. So, we can write here C naught, and that is here Q upon C. C naught is equal to into K upon C here. Q upon C is the potential when it is the dielectric constant is here, that is. So, we can write V naught is equal to 100 into 5, that is here 500 volt. So, the new potential will becomes when the dielectric slab is removed, that is 500 volt. Now, let us calculate the work done required to remove the dielectric slab. Now, work done required to remove the dielectric slab can be calculated by calculating the change in energy. That we can write here change in energy is equal to, in this case, half C naught V naught square minus half C V square. So, we can write half C naught can be written 2 into 10 raised to power minus 6 into 500 square minus half. This can be written here 10 into 10 raised to power minus 6 into this one was here 100. When you put all these values and solve it, you will be getting around here 0.2 joule. So, this is the work done required to remove the dielectric slab.